Hello. So today we are going to discuss about a topic of a fluid mechanics, which is fluid kinematics. So first question is, what is fluid kinematics? So as per the definition, the term itself, that means the kinematics, is concerned about the motion of any body. But in case of fluid, that means the fluid kinematics is basically deals about two things. That means first is how fluid flows and how to describe the fluid motion. Again I am repeating, fluid kinematics basically deals with how fluid flows and how we can able to describe its motion. So coming to this particular point, that means how to describe the fluid motion, there are basically two techniques which we are dealing in a fluid mechanics. First is known as Lagrangian approach and second approach is known as Eulerian approach. Basically through these two approaches we are describing the fluid motion. So now what is Lagrangian approach or the Lagrangian descriptions? So according to this approach, we are basically considered a fluid particles. That means our focus is on the fluid particles, individual fluid particles. So here as you can see that we have taken three fluid particles, that means three individual fluid particles, particle A, B and C. XA is nothing but the position vector of that fluid particle. XB is the corresponding position vector of B particle, and similarly XC represents the position vector of C particle. So again I am repeating, this Lagrangian approach describes, or in this description of Lagrangian approach we are basically dealing with the individual fluid particles. We are not considering the whole fluid, okay? But when we are dealing with Eulerian approach, in Eulerian approach we are not dealing with the individual particle, we are dealing with the, that means the entire volume of that fluid. So what I mean, suppose this is a container, inside there are the lots of fluid particles present. Basically this is contents of, this is a fluid, that means a liquid. Inside it, inside a liquid there are lots of teeny particles are there, that means that liquid particles are there. So suppose when we want to analyze this particular fluid by the Lagrangian approach, then our focus is mainly on these individual particles. That means suppose we want to find the pressure of that, then we have to find the pressure of this particle, and there are millions of particles inside it. So we have to know the nature of each and every particle by, suppose we are dealing with the Lagrangian approach. But in case of Eulerian approach, we need not to worry about the individual particle. Basically we are generally focusing on this entire domain, that means entire volume. This entire domain is also known as the control volume. Control volume means, suppose this is the entrance of this liquid point, and at this particular side liquid are exiting at this. Like that we have already given here a figure. So this is the inlet and this is outlet. Inside it we are analyzing pressure, velocity and like that, okay? These things are basically known as the field variable, okay? This pressure, velocity, acceleration, all are known as field variable. So that field variable may be of scalar or vector. So as we know that pressure is a scalar quantity, so we name it as a scalar field variable, and velocity is a vector quantity, so we name it as a. Now another point is as how we can divide a field variable. The field variable is nothing but it is a function of space and time within this control volume. What is the field variable? It is a function of space and time. So suppose we are dealing with a velocity. So velocity is a vector quantity, that's why v is function of what? Space, that means x-axis, y-axis, z-axis, and time, that means t. So we can write it as v vector is equals to f x, y, z and t. Or in another word, we can also write it as v is a function of x, y, z and t. So this is nothing but a velocity field variable. Like that, suppose we want to write a pressure. So pressure is a scalar quantity, that's why I have not given a arrow sign above it. So pressure is a function of again what? Space, that means x, y, z and time t. So we can represent pressure like this. Okay, now let us solve a problem based on these things. So the question is that here the velocity is given v. It is a function of u and v. U is a velocity, the component of velocity in x-axis, and v is the component of this velocity in a y-axis. Sometimes we can also write it as in a vector form, v is equals to ui plus vj. That means u is a magnitude of velocity in x-axis and v is a magnitude of velocity in y-axis. Okay, so here suppose you want to replace it, so u is equals to how much? It is given here, this is nothing but u and this is v. So u is equals to 0.5 plus 0.8 x. Okay, and a small v is equals to how much? 1.5 minus 0.8 y. So now again, what is required here? What is the question? Determine if there are any stagnation point in it, in this flow field, and if so, where? So first we have to find out whether there is a stagnation point inside this equation or not. So again the question is, what is a stagnation point? That is itself written in the question. The stagnation point is defined as a point in the flow field where the velocity is 0. That means inside a flow field, that means inside this v, the velocity is 0. Suppose v is equals to 0. What is the meaning of this one? This means that if suppose v is equals to 0, it means u is equals to 0 and v is also equals to 0. That means it's both the components, one is along the x-axis and one is along the y-axis, must be 0. So at a stagnation point, this is equals to 0 and this also will be 0. So now equating it, so suppose 0.5 plus 0.8 x is equals to 0. That means x is equals to how much? Minus 0.5 by 0.8, which is equals to minus 0.625 meter. Similarly for this one, 1.5 minus 0.8 y is equals to 0. That means y is equals to 1.5 divided by 0.8, which is equals to 1.875 meter. So we have x is equals to how much? Minus 0.625 meter and y is equals to 1.875 meter. So now again, coming to this question, determine if there are any stagnation point. So first question is there any stagnation point? So yes, because v is 0, that means u and v we have kept as 0, so we have a stagnation point inside this equation. So the question again is, if so, where? So where means at this location, at x is equals to minus 0.625 meter and at y is equals to 1.875 meter. At this point as a stagnation point, will exist. Okay.